Welcome student. Today I will discuss volcanism. Very important topics for prelims, mains, GS optional. Getting well now? So volcanism, what is the meaning of volcanism you should understand. There are technically two terms which are interrelated one. One first particular term is volcano and second is referred to as volcanicity. Getting well now? There are two terms, one is volcano and second is volcano. First is volcano and second is volcanicity. Getting well now? The basic difference between volcano and volcanicity is the volcano is just a fissure on the earth surface through which the earth material comes outside. Getting well now? This fissure is referred to as this fissure or vent is referred to as volcano. What is the meaning of volcano? Getting well? Volcano is just a fissure or orifice on the earth crust through which the earth material comes outside. On the other hand, volcanicity is the broad phenomena. Okay? It includes the formation of subduction of the rock in the earth interior, formation of magma in the earth interior. Okay? That is magma chamber. Upliftment of magma up to the earth surface through forming this pipe which is referred to as volcanic pipe. Again creation of vent, that is volcano. Again particularly the material which comes outside and forms the landform. Okay, this is referred to as volcanic cone. This part is referred to as volcanic cone and the upper part of volcanic cone is upper part of volcanic cone is referred to as crater and crater, C-R-A-T-E-R, crater, and if its size is large, it is referred to as caldera. Getting well now? So actually volcano is just a orifice on the earth surface. On the other hand, volcanicity is the broad phenomena which include endogenetic as well as exogenetic phenomena. Those phenomena which are associated with the earth interior are referred to as endogenetic phenomena and the phenomena which occur outside the earth are referred to as exogenetic phenomena. Okay? So the endogenetic as well as exogenetic phenomena are combinedly referred to as volcanicity. Getting well now? It means volcano is the narrow concept, narrow term, whereas volcanicity is the broad term. Getting well now? Again, I am saying that volcanic activity is the tectonic phenomena. It is climax natural phenomena. Okay? Climax natural phenomena. And when it affects the settlement area, it is referred to a natural calamity. Getting well? So what is volcano? It is clear. The volcano is the tectonic phenomena associated with the earth interior. Okay? Actually, it is climax natural phenomena. Mostly it is natural one. Getting well now? Right? It is another thing particularly that large scale nuclear explosion may create volcano. Right? But broadly it is natural phenomena. And when this natural phenomena will affect the settlement area, causing loss to the human and physical resources, then it is referred to natural calamity. Getting well now? Now see, as far as the question of volcanicity is this is magma chamber where magma is created, right? The pipe through which particularly the earth material comes out is referred to as volcanic pipe. This is volcanic pipe, it is clear now? Volcanic pipe, this is vent or orifice on the earth crust, and this is volcanic cone, and upper part of the cone is referred to as crater, and if its size is large, it is referred to as caldera, and if water get accumulated in crater, it is referred to as crater lake. Okay? This is volcanic cone. Getting well now? So these are the features associated with the volcano, right, or volcanicity. Getting well now? Now see, as far as the question of volcanic eruption is concerned, okay, such type of feature This is magma chamber, this is volcanic pipe, right? This is volcano, that is vent, getting well now? This is volcanic cone, and this is crater. When it gets enlarged, it is referred as caldera, right? And when water accumulates in crater, it forms the crater lake. Getting well now? Now see, as far as the question of volcanicity is concerned, the ejection of earth material, material is referred to as particularly volcanicity or volcanic eruption. So you see, there are three particularly type of matter associated with the volcanic eruption. Okay, three type of matters are ejected outside. One is particularly first one is suppose this is volcanic crater, this is crater, and through this crater the material is coming out. Okay, the first particularly matter is in the gaseous form. Some matter come in the liquid form, and some matter come in the solid form. Getting well now? So out of the total material ejected during volcanic eruption, around 60% is in the gaseous form. Okay, 35% is in the liquid form, and 5% is in the solid form. Getting well now? This is the broad composition of different earth material. But out of the total material ejected, 60% is in the form of gas, right? The 35% exists in the liquid, comes in the form of liquid form, and 5% in the solid form, which are the fragmented part of the rock. Right? Now see, out of this 60%, 90% is water vapor. Getting well now? Right? So actually, among the gaseous matter, water vapor constitutes the largest, but among the gas, okay, when the water vapor is the gaseous state, but among the gas, CO2 constitutes the largest proportion during volcanic eruption. Getting well now? If the question will be in which state the matter comes mostly, so it is in the form of water vapor. Getting well? But which gases come out in largest amount during volcanic eruption? So it is the CO2, that is carbon dioxide. Getting well now? Right? There are yet another gases like carbon monoxide, ammonia, etc., sulfur, etc. may come up during volcanic eruption. Getting well now? Now see, one important particular part I will discuss here. You see what happened if magma is produced in the interior part of the earth, okay, and volume of magma is 10 unit, but minimum 15 unit volume of magma is required to cause destruction of the crust, right? Minimum 50 unit of the magma is required to cause destruction of the crust. In this case, no volcanic eruption occur, right? Because volume of magma is only 10 unit now, okay? But when rainfall occurs, right? When rainfall occurs, the rainwater through downward seepage entered in the interior part of the earth and get added with this magma. Consequently, its volume become 25 now. Getting well now? In this case, now this particular volume is quite sufficient to cause destruction of the crust and come out of the earth's surface now. That is the reason. That's why most of the volcanic eruption during on the continental region occur during rainfall season. But this is not so in the oceanic area, because in ocean there is a continuous supply of water. That is the reason why frequency of the volcanic eruption in ocean is more as compared to that of the continental area. Getting well now? Now see, suppose particularly matter is coming outside, okay, out of 25 unit, right? 25 unit, suppose, right, 20 unit came outside and 5 unit remain in the interior part of the earth, okay. So this is molten rock material along with the water vapor now. So there occur reduction in the pressure in the interior part of the earth, right? When most part of the earth material comes out, right? In this case, the very less amount of the earth material remain in the interior part of the earth, okay? And hence cooling start, okay? and when this liquid, this liquid start converting to solid, okay, extensive volume of gases are liberated, and this process is referred to as degassing process, okay. So due to degassing process, you see most of the gases start coming out of particularly crater, and since in this gas 90% is in the form of water vapor, so that's why it appeared like a smoke, and this phenomena is referred to fumarole, okay. What is the meaning of fumarole? You can say that fumarole is the post-volcanic phenomena, okay, and several fumarole exist in Alaska Valley. That's why Alaska is referred to as Valley of Thousand Smokes. Getting well? If the amount of sulfur is more, then the color of gas will appear reddish, and in this case it is referred to as solfatara. Getting well now? So solfatara, fumarole are the phenomena associated with the gaseous part of the earth material. Getting well? Now see, second particularly component which comes during volcanic eruption is the liquid material, which comes through crater through the volcanic pipe, liquid part. So liquid constitute probably 35% of the total material. Getting well now? Inside the earth's surface it is referred to as magma, okay. Outside the earth it is referred to as lava, and inside the earth's surface it is referred to as magma, and outside the earth it is referred to as lava, okay. There is constitutional difference between magma and lava. When molten rock material remain in the interior part of the earth, it contains volatile material, okay. But when it comes outside in the form of lava, when it comes outside, it is directly exposed to the earth atmosphere, and volatile material gets evaporated. That's why it is said that magma contains volatile material, whereas lava not contain volatile material. This is the basic constitutional difference between magma and lava. Getting well now? Again, you see, as far as the question of magma or lava is concerned, so broadly there are two types of magma. One is acidic lava, right? And second is basic lava. Getting well, right? One is acidic lava and second one is basic lava. Getting well? You see, what is the criteria for determination of acidity or basicity is the presence of silica, that is SiO2. Getting well? The lava in which more than 60% SiO2 remain present is referred to as acidic lava, and if the amount of silica is less than 40%, then it is referred to as basic lava, right? So in geography broadly we particularly define acidic and basic lava in this way. If the amount of silica is more than 60%, then it is referred to as acidic lava, and if it is less than 40%, then it is referred to as basic lava. Getting well? But when you will go through particularly chemical composition or from scientific way, you will find that SiO2 is neutral in character, okay. Then how particularly presence of SiO2 can determine whether a lava or magma is acidic or basic in character, it is clear now, right? So you see very important aspect, right? Important aspect is along with SiO2, another important component are carbonate, CO3 minus, which are basic in character. So if the amount of neutral element is more, then the basic element is less. That's why it is referred to as acidic lava, right? But if the silica is 40%, the 60% will be carbonate now. CO3 minus, that's why it is referred to as basic. Getting well now? Now see, as far as the question of acidic and basic lava is concerned, the amount of silica is proportional to viscosity. Getting well now? It means acidic lava will be more dense, more viscous, and basic lava will be less viscous. Getting well now? Okay. Again you see the amount of silica, amount of silica, right, is inversely proportional to period of solidification. Getting well? The amount of silica is inversely proportional to period of solidification. It means the lava or magma which will contain more amount of silica will solidify soon, but lava or magma which will contain less amount of silica will take long time to solidify. It is clear na? So you see, when there occur ejection of acidic lava, since it is dense, getting well now, and it take little time to solidify, that's why it will solidify to form such type of feature, forming volcanic mountain, getting well now, okay. On the other hand, particularly if basic lava comes outside, it is less viscous, takes more time to solidify, and hence it will spread over the large area, and hence plateau type of feature is created. It means acidic lava form volcanic mountain, okay, and basic lava causes the creation of volcanic plateau, right? As for example, you see Dakka lava plateau, right? It will basic in character. Colorado plateau, it will basic in character. The most of the volcanic plateau are the example, are made up of basic lava na, and mountains like Mount Kilimanjaro, okay, Mount Etna, Mount Stromboli, Mount Vesuvius. They are the example of mountain, and hence they are due to the solidification of acidic lava. Getting well? So what is the basic difference between the two? It is clear na? Acidic lava is also referred to as blocky lava, and basic lava is also referred to as sheet lava. Getting well now? Okay. So it means lava is the second important constituent coming out of the Earth's surface, and the third important component coming out of the Earth's surface during volcanic eruption is the fragmented part of the rock. Okay, fragmented part of the rock, right, will come outside, right? Broadly, it is referred to as pyroclast or ignimbrite. Getting well now? You see, if the reagent of erosion will conduct erosion of the, if fragmentation of the rock occur, right, either due to erosion or weathering, it is referred to as a regolith. But if a fragmented part of the rock come outside the earth during volcanic eruption, it is referred to as pyroclast. Okay. What is the meaning of pyroclast? It is clear now, right? It is referred to as pyroclast. So depending on the size, pyroclast, that is solid fragmented part of the rock, are known by different name. The finest size material is referred to as volcanic dust. Again, you see pumic, lapilli, brassia, right, are also the fragmented part of the rock, and largest size rock is referred to as volcanic bomb. Getting well now? Volcanic bomb is the largest size. Getting well? So it means three type of materials gets ejected during volcanic eruption. One is in the gaseous form, which constitute around 60% of the total material, earth material. 35% is constituted by the liquid, which is referred to as lava, and remaining 5%, which is referred to as pyroclast, right, and given different name according to size, right, comes during volcanic eruption. So what is the basic difference between the what type of material comes out during volcanic eruption? Is clear now, right? Now see, as far as the question of type of volcanic eruption is concerned, okay, so according to, you see, according to mechanism, there are two type of volcanic eruption. Okay, one is explosive type, or central eruption type, and second is fissure type, or quiet type. So according to mechanism, there are two types of volcanic eruption. One is explosive type of volcanic eruption. Explosive type of volcanic eruption is also referred to as central eruption type. And second type of volcanic eruption according to mechanism is fissure type or quiet type. Okay. So you see, explosive type of volcanic eruption are mostly associated with convergence of the plate. Okay, convergence of the plate, you know that due to convergence, some part of the rock gets subducted and another part override it, when it will enter in the Benioff zone due to high temperature condition prevailing in the earth interior. Okay, earth interior, it will melt to form magma. Right now, the formation of magma will impart unstability to this system. Okay, and hence magma will try to come outside the earth's surface. Getting well now? But there is no path for the magma to come outside. That's why it will cause explosion of this part and will come outside. That's why it is referred to as explosive type, and also the fissure is highly centralized one. That's why it is also referred to as central eruption type. Okay. Example of such type of volcanic eruption are, you see, Stromboli, Etna, Vesuvius in Mediterranean Sea zone, Fusiyama and Sakurajima in Japan, Mayon in Philippines, Krakatoa in Indonesia. Okay, in North America, Mount Shasta, Mount Rainier, Mount Hood. Okay, in Central America, Mount Jorallo, Mount Izalco. In South America, in Ecuador, you see there two Cotopaxi and Chimborazo are important volcanoes, which are the example of explosive type of volcanic eruption. Getting well now? You see, what are the example of explosive type of volcanic eruption? Mount Etna, Mount Stromboli, Mount Vesuvius, right? They are referred to as belonging to Mediterranean zone or Alpine zone or Intercontinental zone. Okay. Along the marginal part of the Pacific Ocean, there exists a continuous belt of volcanic eruption in semicircular form. So this is referred to as, and in semicircle, this is referred to as the ring of fire or fire girdle of Pacific, or ring of fire girdle of Pacific, or circum-Pacific belt. So it contains Krakatoa of Indonesia, Mayon of Philippines. Okay. Fusiyama and Sakurajima of Japan, again volcano of Kamchatka Peninsula, right? Volcano of Alaska, okay? Volcano of western coastal part of North America, volcano of western coastal part of South America are the part of circum-Pacific belt, also known as fire girdle of Pacific or ring of fire. Getting well now? On the other hand, you see, fissure type of volcanic eruption are associated with divergence of the plate. Okay, when the two plates move in opposite direction, it is referred to a divergent plate. Due to divergence, there occur reduction in the pressure, right? And hence, due to, according to the law of physics, lowering of pressure causes the lowering of melting point. That's why this rock will melt and will start coming out of the Earth's surface through the fissure created due to divergence. Getting well now? So that's why it is referred to a divergent plate. It causes no destruction and hence it is referred to as quiet type of volcanic eruption. Getting well now? Right? So actually these are the, you see, volcano located in Iceland. Okay? Hekla and Helgafell are the important volcano in Iceland. They are the example of fissure type of volcanic eruption. Getting well now? Right? Again, particularly during Cretaceous period, fissure type of volcanic eruption started in the peninsular part of India. Consequently, around 5 lakh square kilometers of the land became covered with the lava, and this lava covered zone is referred to as Deccan lava plateau or Deccan lava trap. Trap is a Swedish word, means a step-like feature. Since the marginal part of the Deccan lava plateau is of a step-like, that's why it is referred to as Deccan lava trap. What is the meaning of Deccan lava trap? It is clear now? Okay. You see, right, these are the example of fissure type of volcanic eruption. So on the basis of plate tectonic theory, we can categorize whether the volcanic eruption is of explosive type or whether particularly it is of fissure type. But one important point, if plate tectonic theory is capable to explain the tectonic phenomena which occur along the marginal part of the plate, that is edge of the plate, okay? Right? Here you can apply plate tectonic theory, okay? But you cannot apply plate tectonic theory to explain the tectonic phenomena which occur in the interior part of the plate, okay? So if explosive type of volcanic eruption occur in the central part of the plate, then you can say that it is due to descending column of thermal convective current. Okay, descending column of thermal convective current may cause explosive type of volcanic eruption or central type of volcanic eruption, central eruption type. And if there is a ascending column of thermal convective current in the central part of the interior part of the continent or plate, it will cause the creation of fissure type of volcanic eruption, as for example Hawaii Island, right? Mauna Kea and Mauna Loa are two important fissure type of volcano located in Hawaiian Island. They are the example of fissure type of volcanic eruption. Getting well now? So what is the meaning of fissure type and what is how it is different from that of the quiet type? It is clear now. Actually fissure type and quiet type are the same, and it is different from that of explosive type or central eruption type. Getting well? So this categorization is on the basis of mechanism. Okay? Again you see on the basis of period of ejection according to, right, according to period of ejection. Period of ejection, right? There are three type of volcano. First is active type. Active type. Second is dormant type, dormant volcano, and third one is dead. Getting well now? So according to the period of ejection, there are three type of volcano. One is explosive type, one is active type. Active type means particularly if ejection of earth material is almost continuous, then it is referred to as active type of volcanic eruption. Best example is Stromboli in Mediterranean Sea zone. Okay, and hence Stromboli, since almost continuous ejection of the earth material occur and the temperature of the earth material is very high, that's why it illuminates, and hence Stromboli is referred to as lighthouse of Europe or lighthouse of Mediterranean. This is clear now? So if ejection of the earth material is almost continuous, to be noted, right? Almost. Okay, continuous ejection for a long period is never possible. Okay, almost, particularly almost continuous, then it is referred to as active type. Okay, but if ejection of the earth material occur after a long time interval like 40 years, 50 years, then it is referred to a dormant type of volcanic eruption, right? Best example is Vesuvius. Vesuvius, also located in Mediterranean Sea zone or alpine zone, is the example of a dormant type of volcanic eruption. It is clear now? Stromboli is active type located in Mediterranean Sea zone, whereas you see Vesuvius is dormant type, right? Because eruption occur after a long time interval. Getting well now? And third category is dead, the volcano which not erupted for a long period and there is no further sign of ejection is referred to as dead type of volcanic eruption. Okay, Demband, Ko Sultan in Gulf region and Mount Kopa in Myanmar, okay, are the Kilimanjaro of Africa is also the example of dead type of volcanic eruption. Getting well now? Right? So actually there are three categories of volcanic eruption according to the period of ejection. One is active type, second is dormant, and third one is dead. If the question will be, when two statements are given, one is Vesuvius is the example of explosive type of volcanic eruption, and second statement is Vesuvius is the example of dormant type of volcanic eruption. Which of the two statements are true? Okay, both are true because Vesuvius, according to mechanism, is the example of explosive type, but according to the period of ejection, it is the example, according to the period of ejection, it is the example of dormant type of volcanic eruption. Getting well now? So there are two type of volcanic eruption, the two typology of volcano. One is according to mechanism and second is according to the period of ejection. Getting well now? Now, the next aspect is in volcanic eruption, you see there are three major zones of the volcanic eruption on the earth surface, right? The first one is referred to as Mediterranean zone or alpine zone. or intercontinental zone. Continental zone. Okay, either Mediterranean zone or Alpine zone or intercontinental zone. This is first categorization. Okay, right? You see, this is Eurasian plate and this is African plate. They converge. They are the example of convergent plate. And here, right, you will find several volcano like Stromboli, Vesuvius, Etna, etc. Right? They belong to the Mediterranean zone or Alpine zone or intercontinental zone. Okay. Second belt of volcanic eruption is circum-Pacific belt. Pacific belt, right, or ring of fire. Or fire griddle or Pacific. Okay, right? First in Mediterranean zone or Alpine zone or intercontinental zone, right? Second is circum-Pacific belt or ring of fire or fire griddle of Pacific. You must keep in mind. You see, this is Pacific plate. Okay, so Pacific plate is convergent from the east by American plate. It is clear, and from the west it is convergent by Eurasian plate, or Japanese plate is also minor plate. Philippines is also minor plate. So that's why there exists particularly almost continuous volcano along this belt, and this belt is referred to as, for example, in Indonesia, Krakatoa. In Philippines, there is Mayon. In Japan, there is Fusiyama and Sakurajima. Right, Kamchatka Peninsula. Again in Alaska, in North America, Mount Shasta, Mount Rainier, Mount Hood. In Central America, Mount Izalco and Mount Jorallo. Again, you see particularly in South America, Ecuador and Cotopaxi are in Chimborazo are important particularly volcanic sites. So they are also the example. They are, and all this belt is referred to as circum-Pacific belt or ring of fire or fire griddle of Pacific. Getting well now, right? You see, both are the example of convergence of the plate. That's why they will be the example of explosive type of volcanic eruption, explosive type or central eruption type. Okay. Third one is, right? Third belt is mid-Atlantic belt. Mid-Atlantic belt. Getting well now, right? So actually, in the middle of Atlantic Ocean, there exists a divergence plate margin. There occurs the divergence of African plate and American plate. African and American plate moves apart now, right? And along this area, there exists several quiet type or fissure type of volcanic eruption, and this continuous belt is referred to as mid-Atlantic belt, right? So actually, the volcano located in this zone will be quiet type or fissure type, it is clear now, and the volcano of this zone will be explosive type or central eruption type, right? And fourth one is intracontinental belt. Okay, intercontinental belt. Intercontinental belt are located in the interior part of the continent. As for example, Mount Cameroon in Africa is located in the interior part of the plate. Again, particularly volcanic eruption which occurred in during Cretaceous period in peninsular part of India is located in the interior part of the international plate. It is clear, na? They are the example of intercontinental plate. Again, you see, right, Hawaii Island. You see, in Hawaiian Island, there is a Mauna Loa and Mauna Kea. They are also the example of fissure type of volcanic eruption, and they are also the example of intracontinental volcanic zone. Okay, so actually these are the important zone on the Earth's surface, right? Now see, as far as the question of landform associated volcanic eruption is concerned, so the landform produced due to volcanic eruption is divided into two parts. Some landform are found on the Earth's surface. This is referred to extrusive landform, EXTRUSIV, extrusive landform. Okay, and certain landform are found in the interior part of the Earth. They are referred to as intrusive landform. Right? Intrusive landform are found in the interior part of the Earth. Extrusive landform are found in the upper part of the Earth. Right? So you see in intrusive landform, you see the largest landform is batholith. Okay, batholith is the largest example of intrusive landform. Okay, again you see, right, if lava magma not comes outside and form the dome set feature, this is referred to as laccolith. Laccolith. This is batholith. batholith. This is laccolith. 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 But if upper part of this landform is concave in character, it is referred to lopolith. Lopolith, right? If it solidify forming wave type feature, it is called falcolith. Falcolith, right? If it is parallel to the earth's surface and of more high thickness, then it is referred to as sill. But if it is parallel to the earth's surface but less thickness, it is referred to as slate. Sill or slate, it is clear na? If it is vertical on the with respect to earth, so this is referred to as volcanic plug or dike. But if it remain inclined, it is referred to as boss. Right? So they are the example of intrusive landform. Batholith is the largest landform. Then laccolith, lopolith, falcolith, sill, slate, volcanic plug or dike, and lastly there is a boss. Okay? These are the example of intrusive landform. If the statement, the wave type feature produced in the interior part of the earth due to volcanic eruption, it is certainly that it is falcolith. No? Okay, dome set feature lapolith, concave feature, it is lopolith, it is clear now? And on the earth's surface, you see the smallest landform which is produced due to volcanic, by the volcanic material, is referred to as cinder cone, ash cone or rent cone. Okay? If acidic lava comes here, then such type of cones are created whose surface is convex. So this is referred to as acid lava cone. Okay? But if the surface is concave, it is referred to as basic lava cone. Basic lava cone, right? Concave.